So the other bit of syntax is the try-catch block and concept. So let's just see it kind of what it looks like, and then I'll talk about why you would want to do that. So imagine we've got a function that will definitely fail. So this will give us a divide by zero error, which in all computery situations is a bad thing. If you divide something by zero, you get infinity, and infinity is bad. So we started off with a try keyword, and that makes an indented block of whatever it is that we want to try. So we want to try doing that thing. We want to run the function do a dum. And then if there's an exception, run the stuff in this other block, in the except block. So what that allows us to do is to try risky things that we don't know if they'll work. And if they fail, instead of the whole program crashing, it handles it. And so that handler, the idea of handling a problem, is what a try catch or try except block does for you. So what you need to do in one of the exercises is say, okay, give me something that's a number, and if it's not a number, it will, instead of crashing, it'll be like, no, you need to give me a number. Now, it's not great to do that for all types of errors. So like, if something goes wrong, handle it this way. You want to be able to say, what is that error? So if you wanted to print like what the error actually is, we can see what that error is, and then we can see how the program is failing. And then there's a third thing, which is a finally. So we do everything we did there, and then in the finally section, it does whatever you want it to do. Now that section there gets executed whether it goes well or it goes badly. So it allows you to do a kind of last thing. So let's have a look at that in real life. We've got a function here. So we've defined it, it does something, and then we're calling it. So let's just run it and see what happens. Okay, good. So it runs, and we, as expected, get a zero division error. So what if we want to be able to make this so that it is just a divider function? So if we got top part and bottom part, if we want to say top part divided by bottom part, and then we call it with 10 and 0, and let's rerun that, we get the same thing, we get another error. Now, if we want to be able to make that function be kind of robust and useful, we should wrap that in a try, and then indent that, and then except. Let's say you are so silly. Okay, now if we run this, what we will see is that it's now printed you are so silly, because instead of completely crashing on this part, it worked just fine. So what if we want to I'll just print this because otherwise nothing will actually be printed. So if we run that, so that it's now dividing it by 2, we run that, and we will see that it will print eventually you are so silly and 5, because it worked fine for the numbers that it's okay with. So that's great. Now, what we want to be able to do here is to say, well, actually, I want to be able to handle these different errors in different ways. So if the top part is, let's say, want to divide a cake in 2, let's try and see what happens if we try and divide a cake in 2. Okay, so it says you are so silly, right? But what if we want to say, well, we can't handle that sort of thing. So let's turn off the try accept for a second and see what error we get when we try and work with just the cake. Okay, we get a type error, which is a different type of error. Okay, so if we just copy the name of that, and so we'll pop the try and catch back on, or try and accept back on again. I keep saying catch because that's how you would say it in another language. So accept type error as E. E is just another variable name like I. You can call it whatever you want. Let's call it my error, just so you can see. So that's going to give you, that'll handle that error, but it won't handle the divide by zero error. So let's try and run this bit of code and see what happens now. Divide 10 by 5, divide 10 by 2, which gives us 5, and then it is, oh, we didn't make that an F string, so it's just printing my error. That would have printed the error, so that's fine, we'll get back to that in a second. And then it has a zero division error. So what we can do with errors is stack them. So we can catch different types of errors, except zero division error as, we can call it my error as well, because that doesn't matter. And then we can say can't dot divide top part by bottom part, and then we can do \n, which gives us a new line, which is kind of cool. So if we run this now, actually we can do that in Python. It's quite a nice little thing to divide lines so you can still read it. So we're starting to get quite a lot of code here, but it's now quite robust code. So if we run that, 2 error messages. So we get, so silly, we can't do that with a string and an int. Can't do a division with a string and an int. We can't divide 10 by 0, we get infinity. Now that's quite a nice error message, right? So it's good to write good error messages, especially for yourself. But the problem we have here is that this will raise on any other type of error as well. So that's often a good thing. You often want to catch errors. It's bad to have errors that you just ignore, because otherwise your program will do something weird and you won't know why. But let's say we want to handle generic errors here. Accept exception as E. We can call it anything you want. So, and then let's print the general error. Now, that's good, right? So that's sort of handling all of those error cases. So what we would potentially want to do here is, let's say we set something up and it doesn't necessarily get taken apart. We can say finally, we can print, let's just print a line of dashes. So let's see what happens here. We've got to handle this, we've got the dashes. So what's nice about this, I don't tend to use finallys because I don't tend to work with a lot of the more complicated things that you could have go wrong. But generally this pattern here is super useful. So there's 2 paradigms in programming which depend on how the language implements rolling back after an error. One is that you want to be able to, if it's expensive to make errors, then you don't want to make them. So you check before everything happens. So you would say, check that this thing is an integer or this is a number, check that this other thing is a number. If it's not, exit early. But Python, that's called look before you leap. Python has ask for forgiveness rather than permission kind of approach. And so it says, let's give it a go. And if it doesn't work, then we'll deal with that. Whereas other languages are like, okay, check first. Don't do anything wrong. Make sure you don't do anything wrong. Whereas Python's like, do anything wrong you want and we can deal with that. So the idea here is that you are just jumping and then seeing what happens if you catch it. So that's a super useful little concept. I'll paste this little program into the notes and you can see it working.